And again, we're off. Let's see how this one works today. Okay, so we're on to section 12 too. We're still gonna be doing angles and stuff, not necessarily triangles. Section 12.2 is angles and angle measures. All I have right here is just an XY coordinate system. You got your vertex or your origin, and we're gonna learn to draw angles on here. And these are gonna be angles in standard position, all right? And you're always gonna have your vertex at the origin. Your initial side is always going to be right there on the x-axis, okay? And if you go this way, which is counterclockwise, that's gonna be a positive angle. And if you go this way, that's a negative angle. Now I'm asking you to remember some things. Your quadrants, they go in reverse order, 1, 2, 3, 4. And we're gonna start learning about degrees and radians. Radians is just another measure, excuse me. So right here, if I have just a straight, that's either gonna be 0 degrees or 360 degrees or 2 pi. Remember, pi is a number. That's 2 pi radians. Then we go up 90 degrees or pi over 2. So pi over 2 is equal to 90. 180 degrees is equal to pi. 270 degrees, 3 pi over 2. Okay, and you can go either way. If you go this way, it's a negative, and then these would swap. If we were going negative, this would be negative 90, this would be negative 270. And you should see that as we go along, okay? All right, so let's look at just first how to draw some angles, all right? You see my throat still, my throat. All right, so let's just do a few examples real quick. Okay, just make sure we learn how we can draw these. Not getting fancy here. All right, let's say I wanted to draw a 150 degree angle, okay? I'm gonna draw a 150 degree angle, all right? So we're gonna start, we got our vertex. This is gonna be our initial side, which it's always gonna be there. And then it's a positive, so we gotta go this way. So remember, this is 90 degrees. This is 180 degrees. So all we're gonna do is kind of estimate, 150, it actually is gonna be closer to 180. So I'm gonna come over here, just gonna draw this, and I'm gonna put the direction I went. So I know that I was going that way. That would be a 150 degree angle, okay? Let's try another one. Hopefully everybody got my phone number correction. You can text me on that anytime, or call me on that even if you need to, or the other one, I don't care which one you call me on. All right, let's say 215 degrees. Okay, again, a positive angle. All right, so we're gonna be vertex, initial side, 215, still going this way. So again, 90, this is 180, this is 270. All I'm looking is the right place. You're not gonna get it exact right now. So we'll be coming over here, it's gonna be closer to 180. Our arrow. That's how we draw a 215 degree. All right, now let's look at a couple negative ones so you can see that. I'm not worried about the radians right now. Radian is just a different measure on your calculator. Okay, so let's give this a shot. Let's do a negative 210 degrees, all right? So now, remember, we gotta go the opposite way. So we still put our initial side here. We're going this way. Now this is gonna be negative 90. This is gonna be negative 180, negative 270, okay? So we're gonna be going this way. Again, 210s between 180 and 270, and probably about there. So I'm gonna just kind of draw it here and go like this. And that would be our negative 180, or sorry, negative 210 degrees. Okay. Excuse me. All right, let's do one more. 400 degrees, let's say. Now, 400 degrees is more than 360 degrees. So that means we're going to have to go all the way around. All right, and it's positive. So again, 90, 180, 270, this is 360. So one time around is 360. We're trying to do a 400 degree angle. So I need to go 40 more from 360, which is going to be in here. So I'm going to start here. Okay. And I'm going to show that I went around by doing this complete circle here. See? Go around and then just come up to about here and stop. And that's where I'd put my angle. Okay, 400 degrees. So that's the basics of angles and angle measures. All right, now we're going to go a little more in depth. These notes are a little longer today, but these will be the last set of notes you have for this week. Hopefully they're going well. I gotta make sure I'm going there. I gotta change the page. I will scan these and put these in. Now the scan notes may not always be exactly the same because I'm using different things. So don't sweat about that. They should both be right unless I make mistakes, which I do. All right, so we're gonna talk about coterminal angles. All right, coterminal angles. So, coterminal angles. Not nearly as scary as they sound. Okay, coterminal angles are two or more angles in standard position. They got to be in standard position on the XY. With the same terminal side. That means where they end. Remember, they all start at the same place. Okay, so we're going to look at what coterminal angles are. Okay, all right, so again, let's just draw a little XY here. Okay, now somebody give me an angle. 40 degrees, awesome. Great angle to go with. So if I'm drawing a 40 degree angle, starting right here, my initial side, it's always gonna be right there. 40 degrees, and it's gonna be not quite halfway, so I'm just gonna go right there. That would be a 40 degree angle, okay? Now remember, every angle is gonna start here. So if I want a coterminal angle, I want an angle that is going to end in that exact same spot. Well, it can't, 40 is 40. I can't say 40 again. But if I were to go all the way around from 40 to get back here, what would I need to do? I would need to add 360 degrees because that's a complete revolution. So that would be a 400 degree angle, okay? So if I come here, let me change colors. And I start here and I go all the way around. Come back to right there, that would be a 400 degree angle. Okay, that's a coterminal. So 40 and 400 are coterminal angles. Okay, now let's say I wanted a negative one. So again, I want to end up here. So if I want to go backwards to get to here, I would start here, go around this way, and I would actually be subtracting 360 degrees, which would give me negative 320 degrees. Okay, so that angle, and I can keep doing this. I can still keep adding multiples of 360 and subtracting multiples of 360 to come up with different ones. Okay, that's all you're doing for a coterminal. So let's take a little practice. Let's do our angle. Let's do a positive coterminal and a negative coterminal. Okay. So let's just start it out. Let's throw one out. 80 degrees. So if I'm starting with 80 degrees, I want a positive coterminal. Just exactly what it says. I want the angle to be positive and I want it to be coterminal with 80 degrees. Okay, so all I got to do is add 360 degrees. 80 plus 360, 440 degrees would be a coterminal angle, positive one. Now if I want the negative one, I subtract 360. That's going to give me negative 280 degrees. So those would be two answers. All right. I know what some of you are thinking, because I'd be thinking the same thing. Let's say I got a 400 degree angle though. Now 400 degree angle, I can add 360 if I want for the positive one. And I could get 760. But since I'm more than 400, see, because subtracting 360 from that is not going to give me a negative. Still going to give me a positive. So both of those are positive coterminal angles. So what I'd have to do to get a negative is I would have to continue to subtract 360. And then I would get a negative 320 degree angle. Make sure that's still on the screen. It is. Okay, good deal. All right, now let's say we did pi or radians, because radians are going to where you guys, some of you guys are going to struggle. Let's say I have 5 pi over 4 radians. All right, and all radian is just a different way to measure an angle. All right, now what you have to understand is that is less than 2 pi. How do I know? Because 8 over 4 would be 2. All right, so the equivalent of adding 360 is adding 2 pi. So if I take 5 pi over 4, and I want to add 2 pi. Now remember, guys, common denominators, that answer is not 7 pi over 4. I'm really adding, what do you divide by? What do you divide by to get to, what do you divide to, sorry, wow. Whew. Let me focus again here. So I need to find a common denominator. Obviously it's 4. So what would go over 4 to make 2? That would be 8. So I'm actually adding 8 pi over 4. So that answer would be 13 pi over 4 would be the equivalent positive coterminal angle. And then doing the same thing, subtracting would be minus 8 pi over 4 would be negative 3 pi over 4. Wow, I had trouble getting that out. So those would be your coterminal angles for that. Okay? Moving on. And there's a little more today. So I'm gonna try to speed it up a little bit. I'm trying to go as slow as possible so you get it, but then I don't want it to be an hour-long video because it'll take 2 days to upload. All right, so where are we here? Now, where are we at? So now let's talk about radians. All right, radians. So radians, kind of like it sounds, it's like the radius of a circle. Let's do with the radius of a circle, actually. All right, so let me draw a little, another one of our little guys here. All right, and I'm gonna draw a little circle on this guy, my little circle, magic circle maker here. Okay. This is gonna be very important. We're gonna be doing a lot with this. All right, and let's say I draw a little angle. Okay, this right here, stopping right there, would be the radius of my circle. All right, and if I put this as theta, all right, then this arc right here, this arc length of the circle, all right, that's going to cut off the same thing if you remember that from your geometry. All right, now remember, 180 degrees is the same as pi. All right, so what that tells me then is that literally 180 degrees equals pi radians. Now we do not have to write the word radians, all right? Don't have to do that. If there's no degree, then you automatically know it's radians. Even if it's not pi, it could be 3.5, and that could be radians. As long as it doesn't say degree, then it is not degrees. It's gotta be radians if it doesn't say it, okay? All right, so let's see how we convert. Let's convert degrees to radians and radians 2 degrees. Okay, so that's what we want to do. Good, every now and then I'm keep checking, make sure I'm still in frame up here. I don't have the perfect setup, but it's working. So 180 degrees equals pi radians. All right, so what's that mean? That means that I need to multiply. If I have degrees and I want to take it to radians, I need to get rid of degrees. So in order to get rid of degrees, when I multiply, I would need my degrees on the bottom. And that means, so there's my ratio, pi to 180 degrees. That's the conversion factor. So if I want to convert 120 degrees to radians, then all I'm going to do is take 120. And again, I know it's got to be pi over 180 degrees because I need these degrees to divide out. So that's going to be 120 pi over 180. You can divide by 10 and get 12 over 18 pi. Continue to reduce that, and that is 2 pi over 3, or 2/3 pi. So 120 degrees would be 2/3 pi. Okay? All right. Now let's go the other way. Now, again, we already know this. The only difference is this is going to swap to 180 degrees over pi because we want degrees in our answer. Okay? So we want the pi's or the radians to divide out. So if I want to convert 7 pi over 4, I'm going to go 7 pi over 4 times 180 over pi. Now, if you get confused, how do you know which one to put on top? Remember, whatever one you want to divide out has to go on the bottom. So I want to divide out the pi. So I'm going to go 7 times 180. See, my degree is still there. That's 1260 degrees over 4, which simplifies to 315 degrees. Okay? So that's where it would be there. So that's converting degrees to radians and radians to degrees. All right, almost there, guys. Almost there. One more page to go as I drop them all over the floor here. Again, if you guys need any help, don't hesitate. Call, text, send a message, email. School Messenger is stinking it up right now, so I prefer the other things. All right, so let's do one little more formula and then one problem, and then we'll be done. All right, so let's get another little circle here. All right, and this is the way we can find arc lengths, or part of the circle. Okay, so let's say I have an angle. This is my little magic circle maker here. Okay, we're just gonna come out. I don't care what the angle is. All right, so if this was theta, if this was our angle, we have our radius, and this is our arc length. Okay, so there's a formula, there's a relationship here. All right, if I can find the arc length, which is S, so this is arc length. So it's how far something would travel along that arc, okay? That is going to equal the radius times theta. Now that's the angle measure. Now very, very important. Very important. It has to be in radians. If it is not in radians, then you have to convert it to radians, okay? If it's in degrees, you have to convert it, all right? Now, sometimes you have one or the other of these things, so you can manipulate these. If I'm trying to find R, then R would be what? It would be, get R by itself, it would be S divided by theta. And if I wanted to get theta by itself, it would be S divided by R. Those are just other options here. Okay, so one little quick problem, and we'll wrap this up. All right, so let's say we have a tire. I don't know why we would have a tire, but we got a tire. Maybe there's a logo on it, I don't know. And it has a radius of 33 inches. Okay. It rotates 3/4 of the way around. Okay, how far does the outside of the tire travel? No pause there. So in other words, again, think of a tire as this plain old circle. All right. No, that's not a good place to draw it. Let's change that. Okay, so there's our tire. Let's say we got a little magic mark on it right here. Okay, there's our center. All right. So we want to know if this travels 3/4 of the way around it. Let's start right here at the middle so we can do a nice little, our little 90 degrees here. All right. All right. So 3/4 of the way around. Right? 3/4 of a circle. That would be down to here. So this is going to travel. It's going to come all the way down to here. So it's going all the way around there. That's 3/4 of the way. And if you remember, that's 270 degrees, but we can't use degrees. We need radians. So that's 3 pi over 2 radians. We don't have to write radians, okay? So use my formula, S equals R times theta. So S is what we're trying to find out. We're trying to find out if there was a mark right here, how far would it travel along this outside to get to right here? All right, so S equals the radius. There it says the radius of the tire is 33 inches. So 33 inches times 3 pi over 2. So my exact answer would be 99 pi over 2 inches. Okay, that's exact. All right, and if I wanted to estimate it, then I would just do my math on 99 times pi divided by 2, and it'd be approximately 155.5 inches. Okay. All right, guys, this will be our last set of notes for the week. This is our third set of notes. I am going to put up a practice worksheet for you. There are 2 assignments on there that you need to do to make sure you get graded. Some of you have already done them. One of them is a 1-point true or false question. The other one is a 7-question quiz, and you get 2 attempts at it. Okay, so make sure you're getting those things done. Keep checking eCampus. Text me, call me if you need to during the hour, whenever you can. If I'm available, I'll answer. So hang in there, guys. We'll get through this together. I think we're off to a good start. Bye-bye.